Hello everybody, I'm Nick, and in this video I'm going to introduce you to the two MediatR features you probably never heard of or used, and that might be for good reason for at least one of them, but we're gonna see all that in this video. If you like that type of content and you want to see more, make sure you subscribe, ring the notification bell, and for more training, check out nickchapsas.com. Now, before I move on, quick reminder, I am running my in-person 2-day workshop, Introduction to Effective Testing in C# and .NET, in the following conferences that you see right now on your screen. For now, it's NDC Oslo, NDC Sydney, .NET Days Romania, NDC Minnesota, and NDC London, and there's links for all of them down below, and I will update the description as more events are announced. Now, back to the video. All right, let me show you what I have here. So I have a simple API over here, and this is basically the same thing that comes out of the box with a boilerplate ASP.NET Core Web API. However, this has been modified out of the box to use MediatR. So as you can see, I have my get weather request MediatR, and I'm doing it by city. I'm still using the same in-memory fake generation because I don't want to connect it and spend time connecting it to a real API, but I do have a fake 50 millisecond delay to simulate that I'm calling an API. And then I have my get weather request, which returns an enumerable of weather forecast, and that's it. And I'm doing all my wiring up here with this line of code. And if I go ahead and I debug this, then this is what I get. I can go to Postman and call this get weather for London, and I'm getting the weather, and this is coming from the API you just saw right here. And this is probably the functionality you're familiar with. The idea that we have a request, then we have some sort of handler that MediatR is sending the request to by calling the send method, and then we're getting a response back, and we're doing something with this. In this case, we're returning it. It's this idea that I have some request, I throw it in the void, and the void returns something back without me having to know where exactly it went. By me, I mean, in this case, the controller, and how it got that response. And it's great for decoupling your layers. Now, this is not the only functionality MediatR has. Far from it. This is just one of now 3, because recently, I think in version 9, there was a new one added. We're gonna see that. But before I show you that, I wanna show you the one it had for a long time now, and that is notification support. So currently, if I did not have a handler over here, if I go ahead and I just comment out this handler to get the weather, obviously I'm getting no compilation error, because the idea of MediatR is you're sending the request and you don't know where it's going, meaning there is no direct coupling between the send method and the handler. So in compile time, the system doesn't know if I have a handler for it. Now, when I press run, this all runs fine. However, if I call this endpoint now, I'm getting a huge exception saying there was no handler found. And this is because the relationship between that request and that response is 1-for-1. So one request needs to have one handler to get that response back. If I have no handlers or more than one handlers, I'm gonna get that exception, because you cannot send that to more than one. The relationship is 1-for-1. However, notifications is this idea that you can have one notification and you don't know if you have 0, 1, 2, or 10 consumers. The notification will be published to all of them. So it's a bit of a one publisher, many consumers relationship, as opposed to one publisher, one consumer relationship with the send method. Let's see how that works. And in our case, I'm going to add a new endpoint that allows me to create a weather warning. So say there's a tornado coming or whatever. And then in my code, I'm going to notify anyone who's interested in weather updates. And in this case, it will be just handlers I make to demonstrate the feature. So it would look something like this. I would have a post request called weather warning with this weather warning body. If I go to the body of this, it just has a message. It's not going to be something very sophisticated. I just want to show the feature itself. And then in here, it's going to be very simple. It's going to be var notification. In this case, it's not a request by wording. It is a notification. And I'm going to have a new weather warning notification. I'm going to go ahead and create that. And I'm going to pass down actually the message, because that's, I think, the only thing it's going to need. So I'm going to create a new model here, and this, instead of having to implement the I request, it's going to have to implement the I notification. And as you can see, I don't have an overload for return type. The notification doesn't actually return anything. It returns task, and that's it. So if I went ahead here and I said message and I removed the setter and I added it in the constructor, and that's it, then they should compile fine. And because I have no response, I don't really need to say var response. All I need to say is await MediatR publish in this case, and this is the pub sub scenario of me publishing something to multiple notification handlers, and I'm gonna pass down the notification, and that's it. Now, just so this compiles, we're gonna say OK back, but this is all the code I have. So I have my notification and I publish. And in this case, I'm not going to create any handler for now. I'm just going to run this. And then I'm going to go to Postman and I'm going to go here and call this weather warning endpoint and say message, a thunderstorm is coming or something. I'm going to send that and it says OK. It doesn't break, it doesn't throw, even though I don't have any handlers for the notification, because it doesn't care if I have any. It doesn't care if I have any 1, 2, or 3. All it cares about is publish this to the void. Obviously, you can't return anything back. It just returns task which is being awaited, so it returns nothing effectively. And that's it. Now I'm going to go ahead and create my first handler. I'm going to say weather warning handler. And that's it. And that's going to be an I notification handler, and the request is weather warning notification. We're going to implement that, and I'm just going to actually add a fake delay. So I'm going to say async await task dot delay for, let's say, 2 seconds here. And then I'm going to say console dot write line hello from, and we're going to use the name of the handler over here. So hello from weather warning handler. And that's it. I'm going to go ahead and run this API again and now call this endpoint and see how this takes 2 seconds to respond. But then in the console, it says hello from weather warning handler. All good. Now, if I go ahead and I add a second handler, so I'm going to go ahead and duplicate that and say another weather warning handler. Just copy that, paste it here. And it's still the exact same object. I don't have to worry about having more than one request being consumed by one handler, because that's the whole point. Now, in this case, I'm going to say 3 seconds for this. And actually, I misspelled that. So let's go ahead and fix it. Another. Here we go. And I'm going to put that name here as well, so we can differentiate the two. So we're going to run the project again and call that API endpoint. And as you can see now, it's going to take some time and then respond with OK, that it actually did send the requests back. So it actually found both handlers that consumed the exact same notification, and it triggered them both here. Now, I don't know if you noticed it, but look how long it took for this thing to return something back. So previously it was 2 seconds because I'm waiting for 2 seconds. Now this took 5 seconds. But I'm not waiting 5 seconds anywhere. It's 3 here and it is 2 here. You would expect that the two things would run in parallel. However, it is not like task.whenAll. It is more of a chain loop of awaiting the first thing, something happens, awaiting the second thing, something happens, and so on, which makes it not a great idea for like in-memory eventing sub-mechanism, because you would hope that everything would execute in parallel, which it doesn't. So that's probably why it's not really being used, because you'd have to await everything, one thing on top of each other, which is a weird choice. Like, I get it from a library standpoint, but like, what is really the use case for it? It's a bit of a weird design choice. So that's probably why this is not really used, but at least now you know it is there. And if you have a use case for it, you know, it might work for you. It might be that you want to have this idea of sending a notification and more than one handlers can actually consume it and do something with that data without having to send it to everyone individually with a different type. So I'm going to stop that and I'm going to show you the relatively new feature of MediatR, which I actually really like, and I get why it was added. It's a very nice idea, especially seeing how MediatR is used in our applications. And that is the streaming capability. So I'm going to go to the controller and I'm going to create a new endpoint. And this endpoint is going to be a weather updates endpoint per city. So you can actually subscribe to a city and get updates in real time. Let's say once every 1 second, you're getting an update in the temperature and how it's changing. Now, obviously, we're going to do all this in memory and fake it, but it's not unreasonable that you'd want to know some real-time updates for something. And APIs in ASP.NET Core actually do support it. The way to do this is to use the added async enumerable feature of .NET and use the same weather forecast object over here and say weather updates. And that's it. And I'm going to use the same body as here. So I'm going to say from route city, and I'm going to use a cancellation token as well. And you're going to see why that's kind of important in this case too. Now that way I can actually stream a response back from the controller. And now with MediatR supporting that feature, I can actually pass down that responsibility to MediatR and have that do all the compute in there in a very nice decoupled and encapsulated way. So here's how I'm going to do that. first, I'm going to create the request I'm going to send down. So I'm going to say weather update stream request, and I'm going to have that implement the iStream request, and that's going to return a weather forecast object. And the only thing I'm going to have is the city to simulate querying for a single city. So I'm going to say that, pass it down to the constructor, and that's it. And now I'm going to create the handler, and the handler is going to be a weather update handler. And what this needs to implement is the iStream request handler. And the first parameter is just the request we just created. So weather update stream request, and the response is what you're returning. So in our case, weather forecast is the object, and then we implement the only handle method this thing needs, and it has the request as an object, the cancellation token, and it returns the iasync enumerable, which is the same thing our controller returns. That's important. We're going to see why. So first, let's create some fake summaries that we're going to use to fake the weather we're going to return back. And then I'm going to say while cancellation token is cancellation requested, and then negate that. So while the cancellation token is not cancellation requested, then let's have it delay for a second. So every second we're going to get an update, and then pass down the cancellation token. Now this says obviously it needs to be async, so I can turn this into async, and we're missing the yield keyword. This is why this is complaining. So now I'm going to say yield return, and I'm going to say new weather forecast, and we're going to pass down the same randomization of temperature in Celsius and the summary of the method. And the last thing I want to do here is respect rider suggestion to add the enumerator cancellation attribute, and that's it. And now I'm going to go back to the controller, and I'm going to add my request. I'm going to say stream request equals new weather update stream request, and pass down the city. And then I'm just going to say return mediator.createStream. This new createStream method is what accepts the stream request, and I'm going to pass down the cancellation token as well, because I want to be transferred down so I can actually cancel this thing, because if I don't, it's just effectively an infinite loop. So with all that in place now, I can go ahead and debug this. However, Postman doesn't actually support this as a feature, this idea of streaming my JSON response. So what I'm going to do instead is copy the curl snippet over here and go to the console and paste it and run it from here. And as you can see, every second now, I am getting one part of that JSON response. So I'm effectively just streaming my response. And if I go in rider and I add a breakpoint, you can see this happening every second and every second and every second. And actually, if I go ahead and I press Ctrl+C and cancel this, then you can see that the cancellation is respected and I'm not actually hitting that breakpoint anymore, even though the application is running. And that's just a way now to stream your responses by using MediatR as well, which was kind of a deal breaker beforehand because people wanted to use MediatR, but they couldn't because MediatR didn't support the streaming capabilities. But now it does, and you can all use it if you have the use case. I will make in the future a dedicated async enumerable video because it's such a cool feature and I don't really see it being used that much. So make sure you subscribe to don't miss that. But this is how you can do it now if you have a use case with MediatR. I don't think the notification feature is really well thought out and it's worth your time, really. I think alternatives are better. However, the streaming capabilities are really, really cool, and it's something I'm personally using as well. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreon, so make it as easy as possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.